Hopefully you noticed pretty quickly that this system is not set up for the Gauss-Jordan method, that if I start my augmented matrix right now, that it's not going to be correct because my constants are on the left side of the equal sign, not on the right side. So I need to correct my system to begin with, and I need to subtract 42 from both sides on the first equation, and I need to add 17 from both sides on the second equation. And now if I use Gauss-Jordan method to solve this, then my augmented matrix will be -15, -3, -42, and then 6, 1, and 17. Now my constants have the correct sign on them. So I want to put that augmented matrix into my calculator. I want a calculator page. And then to enter my matrix, I'm using this button that's in red to the right of the 9. And then I want that matrix that's right in the center so that I can change the size of this if I need to. I only have 2 rows and I have 3 columns. This gives me a template and I can enter those numbers. So when I press enter, I have my augmented matrix entered into the calculator. Now I want to get a 1 in this position right here. And so that means I need 1 step. I'm going to go to the catalog to get that step, and multiply row is a single step operation. So I want to multiply row 1 by a number that's going to give me a positive 1 right there. So I need to multiply by -1/15. Then I need my matrix argument there. And then comma row 1 is the row I'm changing. And I press enter. I check my results. Those results look good, so let me write down my work. So what I did to get the next matrix was to multiply by -1/15, and I multiplied row 1 by that number. That gave me a positive 1 right there. It also changed these numbers, but if you notice, the second row in the matrix did not change. Now my second chore is to get a 0 right here where the 6 is, because I'm working on this first column. To get a 0, I need 2 steps. So I go to the catalog and I choose mrow add. That has 2 operations in it. I need to add a -6 to this 6 to make it 0. So I'm going to multiply the first row by -6. Always your matrix is your second argument. I'm multiplying row 1, which is not going to change. I'm changing row 2, so the 2 is the last item in my argument, and then I press enter. So I have the 1 in the first position, and I have a 0 on the second row of the first column. So I'm going to go back to my work, and I'm going to write that down. So I multiplied row 1 by -6, and then I added it to row 2. When I move to the second column, the first thing I want to do is get the 1. I want the 1 to be in this position, which is diagonal from the 1 that I set up in the first column. To get a 1, there's only 1 step, so I go to the catalog. I choose multiply row, which is 1 operation. I want to multiply this number by a number that will give me a positive 1. So negative times negative is positive, and 1/5 times 5 is 1, so that number should work. Second argument is always the matrix. And then there's a single operation, so it's just what row am I changing, and I'm changing row 2. Now I have 1s on the diagonal. I haven't messed up my 0 in that position, so I need to go to my work and write that step. So I multiplied row 2 by -5. Finally, I need to get a 0 in this position where the 1/5 is. There are 2 steps to get a 0, so I go to the catalog and I choose mrow add. 2 operations, multiply and add. I want to add -1/5 to the 1/5 that's here, so that's the number, -1/5, that I'm going to multiply by this 1 and then add it to that row to get the 0. So, comma matrix, comma multiplying row 2 where the 1 is, and changing row 1. The row that you're changing is always the row that you end your command with. So now I have 1s on the diagonal, 0s there, and my work is done. I do need to write that last step on my work. So this was my final step, to multiply by -1/5, multiply row 2 by -1/5, and then add it to row 1, and this is the result that I got. The matrix itself is not the answer. Remember, we want to write the answer as an ordered pair, and so the x value of the ordered pair, x equals 3, and the y value of the ordered pair would be y equals -1. So the ordered pair is 3, -1.